In this video, we're going to talk about 2.5 Objective 2, where we evaluate limits at infinity. We're going to do this with a variety of Calculus 1 techniques. We're not going to use our Calculus 2 techniques yet, since this is still our Calculus 1 videos. So let's go ahead and find the limit of 7x to the 24th as x approaches negative infinity. As x gets to be a big negative number and I raise it to an even power, that's going to be a big positive number, times 7 is still going to be a big positive number that's going to approach positive infinity. If I wanted to look at the graph of this, it would be something like this, just be growing really fast. But as I'm going to this left-hand side and getting to a big negative number, going up to a big positive number. We'll evaluate by some graphs in a little bit. This one is the same thing as limit as x goes to negative infinity of 1 over x to the 6th. So that's going to be a graph that looks more like this. It's going to be changing quicker than I'm drawing it, but as I go to negative infinity here, I'm getting close to the horizontal asymptote of 0. Another way that I can think about that is if I have any constant over either type of infinity, it's going to go to 0. That's going to be important here in a little bit when we deal with rational functions. All right. Now I have a limit as t goes to negative infinity of negative 15 over t to the 6th. So again, when I have a constant divided by infinity here, we're going to go to 0. Now we're going to use our sum difference rules. Limit as x goes to negative infinity of 2 plus limit as x goes to negative infinity of 2 over x squared. So that's 2 plus, and this constant divided by infinity here is 0. So our answer is going to be 2. Let's determine the following limit at infinity. So we're getting close to a big constant, 300,000, and g of x is getting close to positive infinity. This is going to go towards 0. It doesn't matter how big of a constant is in the numerator. Infinity is going to cut up that constant into infinitely many small pieces that are each close to 0 size. All right, let's split this up with this monomial here. Limit as x goes to negative infinity of 9 over x to the 3rd plus limit as x goes to negative infinity of 2 over x to the 2nd plus limit as x goes to negative infinity of 3. And we're going to get 0 plus 0 plus 3. It's going to give me an answer of 3 here. Let's evaluate these limits here now. Limit as x goes to infinity, 1 minus x over 2x. So let's multiply top and bottom by 1 over x. Limit as x goes to infinity of 1 over x minus 1 over 2 is going to be 0 minus 1 over 2 is a negative 1/2. Now let's look at this next one. Limit as x goes to negative infinity of 1 minus x over x squared is going to be limit as x goes to infinity of 1 over x squared minus 1 over x. 0 minus 0 is 0. And limit as x goes to infinity of 1 minus x squared over 2x. So limit as x goes to infinity of 1 over 2x minus limit as x goes to infinity of x. So this is going to be 0 minus infinity is going to be negative infinity. Suppose the function g satisfies the inequality 29 minus 19 over x to the sixth is less than or equal to g is less than or equal to 29 plus 19 over x to the sixth for all non-zero values of x. Evaluate the limit going towards positive infinity and the limit going towards negative infinity. In both cases, the limit is going to be 29 by the squeeze theorem. That if I take the limit, I'm going to take the limit of all three pieces, and this is going to squeeze down to be between 29 in both cases. The graph has a vertical asymptote at x equals 2 and a horizontal asymptote at y equals 4 and another horizontal asymptote at y equals negative 3. The y equals 4 piece is here as x goes to negative infinity. The y equals negative 3 piece is over here as x goes to positive infinity. So that's the question. As I go to negative infinity, I get close to positive 4. As I go towards positive infinity, I get close to negative 3. As I get close to 2 from the left, I go towards positive infinity. And as I get close to 2 from the right, I go to negative infinity. All right, now we're going to squeeze some stuff here because we know that sine of 17 theta over 169 has to stay between negative 1 over 169 and 1 over 169. We're going to see if we can, oh, that says 16 theta. That's much better. All right. So we're going to say sine of anything has to stay between negative 1 and 1. So our limit here is going to squeeze, no matter whether theta is going to positive infinity or negative infinity, is going to squeeze to be 0 on both sides. So this is going to have to be 0. Let's see what we can do with this next one. So each of these, let's look at this sine squared thing here. So this is going to be 9 plus, and that's going to go to 0. And then we have plus this limit. All right. And this limit here, we know that the top is going to have to stay between 0 and 1. So we have 0 less than or equal to 1 over x squared sine squared x cubed. For x squared, take the limit as we go to infinity. And this is going to have to stay between 0 and 0. So that's 9 plus 0 plus 0 is 9. right, now we have some limits here that I'm just going to think of the graph here. This is an x cubed that has a positive leading coefficient. So it has this kind of shape. As I go to positive infinity over here to the right-hand side, we're going to go to positive infinity on y. As we go to negative infinity for a function with a positive exponent odd power here, we're going to go towards negative infinity. Let's now go ahead and use that technique I was talking about before. Limit as x goes to infinity here, and I'm going to multiply everything top and bottom by x to the negative third. So this is going to be 16 plus 5x to the negative first minus 5x to the negative second over 56 plus x to the negative first plus 5x to the negative second plus 5x to the negative third. And any of the terms with negative exponents here are going to go to 0 as I take the limit going to infinity here. So this is going to be 16 over 56. Let's reduce that. That's 4 over 14 is 2 over 7. Now let's go ahead and look at this limit as I go to negative infinity. Degree of the top is greater than degree of the bottom. Let's go ahead and use the same technique though to get rid of the x in the denominator. I'm just going to multiply this by x to the negative first, top and bottom. So this is going to be limit as x goes to negative infinity of 4x plus 3 over 1 plus 5x to the negative first. That one's going to go to 0. We're going towards negative infinity plus 3 over 1 is going to go to negative infinity. Your teacher may or may not want you to go ahead and put negative infinity in like that. Just don't use an equal sign if you do it. Use an arrow to say it approaches that, because infinity is an idea, not a number. So I can't use an equality symbol for it. Let's go ahead here and divide everything by x to the 6th. Limit as x goes to infinity of negative 5 over x plus 34 over x to the 6th over 8 plus 1 over x minus 5 over x to the 5th is going to be equal to 0 plus 0 over 8 plus 0 minus 0 is 0 over 8 is 0. All right, now we get some more interesting problems that have square roots in them. So watch out for the fact that we need to have be aware of the fact that that equals that and that equals that. So I'll be using that here. Or I might be using my same rule where I'm multiplying by 1 over something. So let's go ahead and let's pull this w to the 4th. Let's pull it out with a square root, and let's see what we have cancel out here. So this is going to be Because I'm going to positive infinity when I pull that out, I'm on the right-hand side. It's going to be equal to the same thing. I'm not going to have to add a negative in. So this is going to be w squared comes out as the square root of w to the fourth. It's going to be 49 plus 2 over w. And then this is 14w squared plus 4w plus 1. So that's going to give me limit as this is w goes to infinity of 14 plus 4 over w plus 1 over w squared over the square root of 49 plus 2 over w. So this is going to be 14 plus 0 plus 0 over square root of 49 plus 0 is 14 over 7 is 2. Now I'm going to use a different technique here, and I'm going to say that this x here is the same thing as the square root of x squared, as long as x is positive, right? We have this, but it's not. It's on the negative side. I'm going to negative infinity, so I'm going to have to say that this is the opposite of the square root of x squared here. So I'm going to make this a limit as x goes to negative infinity, a negative, and then big square root of 289x squared plus x over x squared, limit to x goes to negative infinity of negative square root of 289 plus 1 over x, limit as x goes to negative infinity, negative root 289 is going to be a negative 17. So if you don't have that one memorized, 17 squared is 289. Just a few more problems here. Some with square roots, some with trig functions here that we're going to squeeze. So let's go ahead, and they give us the hint here to multiply top and bottom by the conjugate of this thing to find the limit. So limit as x goes to infinity of 4x to the fourth minus, then that's going to be 4x to the fourth plus 11x squared over 2x plus the square root of 4x to the fourth plus 11x squared. And we're going to end up with limit as x goes to infinity of 11x squared over 2x squared plus, and I'm going to positive infinity, so it's okay for me to take this x squared out of here, make this 4 plus 11 over x squared like that, divide everything by x squared is going to be 11 over 2 plus root 4 plus 11 over x squared is 11 over 2 plus square root of 4. 2 plus 2 is 4, so this is going to be 11 over 4. And this is negative because that negative got distributed. Just missed a negative sign. There we go. Squeeze theorem here, since we have sine or cosine. So we're going to be keeping cosine of x over x to the fourth plus 4 between -1 over x to the fourth plus 4 and +1 over x to the fourth plus 4. And -1 over this is going to go to infinity. That's going to be 0 when I take that limit. Limit as x goes to infinity, cosine x over x to the fourth plus 4. This is also going to be 0, so that limit has to be 0. Let's get rid of the x to the sixth here in the numerator. Make this limit as x goes to -infinity of sine x over 7x to the second plus 2. And then I'm going to say sine of x over 7x to the second plus 2 has to stay between -1 over 7x to the second plus 2 and a +1 over 7x to the second plus 2. And as I go to -infinity, this is 0 and this is 0. And so that limit goes to 0. Let's go ahead here and evaluate the limit both at positive and -infinity here. So let's rewrite f of x as 9 plus 2x to the -3rd over x to the -3rd minus 2. Take the limit as I go to positive infinity, and that's going to go to 0, 9 plus 0 over, and that's going to be 0 minus 2. That's going to be -9/2. And same thing when I go to -infinity. This is still going to be 9 plus 0 over 0 minus 2. That's also going to be a -9/2. Right? Let's rewrite this one here as f of x equals, and it's going to be a positive x to the 6th square root of 16 plus 5 over x to the 12th, 12x to the 6th here. If x is greater than 0, can't be equal to 0 there because then I have an undefined denominator, and it's a -12x to the 6th over x to the 6th square root 16 plus 5 over x to the 12th when x is less than 0. So my limit here, these will cancel in both cases. I'll just vary by a sign here. So so 12 over root 16 is 12 over 4 is 3. And I come at it from the right-hand side, and it's going to be -12 over 4. It's going to be -3 when I come at it from the left-hand side. It says that it's 3 in both cases. Let me go ahead and look at my calculator here and see what's going on. I have 12x to the 6th divided by square root of 16x to the 12th plus 5 . Okay, and looking at the graph, it definitely approaches +3 on both sides. So let's go ahead and do this. This way instead. Let's say this is going to be that. That would have been the better way to do it. And no matter whether this is positive or negative infinity, this is going to be a positive number. This is going to be a positive number. The same positive number. These are going to cancel. And that's why it's +3 for both of them. All right, that's it for this video. We'll come back next time and we will talk about 2.5 objective 3. See you for the next video.